In geometry we study congruency and similarity. Congruency, which was covered in a previous section, is when we study figures that are both equal in shape and size. For example, the two triangles here are congruent because their corresponding angles and sides have the same measure. In other words, they both are exactly alike. That's why they're called congruent. Now these triangles have the same angle measure. In other words, they have the same shape, but they do not have equal sides. Because they only meet one of the conditions of congruency, three angles that are equal, they are not congruent. They are similar. Similarity is when you have the same shape of the object, but the object is either bigger or smaller. In the case of triangles then, if two triangles have corresponding congruent angles, then they are similar. This is called similarity by AAA. Now, the key to understanding similarity in theory and practice is that all corresponding parts of items that are similar must be, by definition, also proportional. And all the rules of ratios and proportion apply to it. A toy model car done to scale is a good example of similarity. Now first let's talk about ratios. A ratio is a fraction where we compare two quantities. In the case of geometry, we'll take the measurement of two triangles. For example, this triangle has a base of 12, and this triangle has a base of 24. The ratio between the bases is either 12 to 24 or 24 to 12. If we decide to go with the ratio from small to large, we must then keep the same small to large ratio throughout the computations for answers. At 12 to 24, the ratio reduces to 1 to 2. In other words, proportionally speaking, if the figures are similar, then they have to keep the same proportion of 1 to 2. If it is given that the triangles are similar, this is the sign of similarity, then this side must be 30, because its corresponding side in the smaller triangle is 15, and the 1 to 2 ratio was established earlier. And if this side is 16 in the smaller triangle, then this side must be 32 in the larger triangle, again because the ratio is 1 to 2. Now, let's say we don't know that the triangles are similar. Well, in that case then, these three ratios must be the same, 1 to 2. So if the sides of two triangles are proportional, if they have the same ratio, then the triangles are similar. Let's try another example. In here we have that triangle FGH is similar to triangle JKL. Notice the sign for similarity. Now, once we have established that the triangles are similar, then corresponding angles are equal, and corresponding sides are proportional. In other words, by writing ratios as equalities using proportions of corresponding sides, the missing sides FG and JL will be found. First, we select the two corresponding sides that are represented by both triangles. In this exercise is side GH and KL. GH is 15 and KL is 21. Set up a ratio with these two sides. So for every 15 units of the smaller triangle, there are 21 units of the larger triangle. By reducing them by 1/3, we find that the scale of the triangle is 5 to 7. In any case, to find the answers, we don't need to know the scale. So the proportion 15 is to 21, as FG is to 23.8, will tell us the value of FG. Solving the proportion. Multiply 15 by 23.8. We get 357. Divide 357 by 21, and the value of FG is 17. We now do the same thing to find JL. 15 is to 21 as 8 is to JL. Notice this time JL is in the denominator, while FG was in the numerator. This is because we decided to go small triangle to large triangle from the start. In any case, to solve the proportion, 21 times 8 equals 168. 168 divided by 15 is 11.2. JL is 11.2.